So we'll just get past a couple things here and we'll get right into it. So I've been over the last couple of years trying to make sure all my presentations have actual examples that you can either see the code or run the code yourself. So I have all of this stuff out in GitHub. And so if you want to follow along, you can go to this URL. If you want to look at this later, again, the slides will be provided and you can get to this. These scripts are things that are as is. They're meant for this session. They're meant for, if you want to say, training. Do not run these in a production system. Don't run this in something your development teams use. These scripts can do some bad things, but they're meant to help teach you how maybe the optimizer works or how SQL Plan Management works, and they might, just drop all your baselines and stuff like that, which you don't want to do. So definitely, I run them in like I have a VM here I build in my home lab. If I'm traveling, I put it in a container on my laptop and I run it, and these are things I blow away afterwards. So definitely don't run them anywhere where you need something to stay permanent. So this is that GitHub repository. All the scripts are here. You can look at them and step-by-step instructions of how to run them. And I will be running them live during the session here to actually see things work. So we're going to just go ahead and start. And that first step just downloads the scripts. And then I'm going to go ahead and get into that directory and start the setup stuff. And this just creates a user that we will use throughout the lab. And then I'm going to create some tables in that schema. And let's see, tables. And so this is just the data and tables we'll be using for the lab. So that's in the background. So we'll continue with our presentation. Again, if you have questions during the presentation, please pop them into the Q&A box. I'll try to get them as we go. And if you want to look at these scripts as we go along, you can head to this URL, bit.ly, 3 lowercase t, capital P, lowercase v, capital P, lowercase j, capital D. So again, feel free to look at those later also. Okay, so again, we're going to talk about SQL performance tuning. So you have a bad SQL statement. Once you identify that the SQL statement needs to be tuned, maybe you tune it, then you have to do something to make that SQL statement change. You have to do some kind of change to the system. And so really our options for changing are to change the environment, maybe statistics, missing an index or something around the objects or around the database. Maybe we have to change the SQL statement itself, recode it, or add a hint. Perhaps we can apply a SQL profile. Perhaps we can apply a SQL baseline, which is what we're going to talk about in depth today. You could use something like SQL rewrite, or you could apply a SQL patch. So those are the ways, once we know how to make a statement run better, these are the ways we can apply that fix or fix the statement so it runs better. The general steps are: 1 is to identify the statement that's running poorly, then 2, figure out how to run it better, right? Maybe, like I said, use that index or something, and then 3, apply one of these fixes. Okay. So our agenda, we're going to talk about what SPM is. We're going to talk about capturing plans. We're going to talk about viewing that information and evolving. In the appendix of the slide deck, I have moving and fixing baseline information in more detail. Otherwise, the session just kind of runs too long. So, oops. So what is SPM? So SQL Plan Management is part of what Oracle calls their plan stability features, right? So you have a SQL statement and you want to run fast all the time. Sometimes maybe it runs and chooses an execution plan that is not as fast, right? An execution plan is a way or the steps of going to get the data you've asked, right? Maybe to go use an index or not use an index, to do a full table scan, do nested loops or hash joins, etc. If there's more than one way to run that SQL statement and one of those faster than the other, we use what's called plan stability tools to try to have the optimizer choose the one that we think is fastest, right? This is a feature, SPM, that came out in Oracle 11. It replaces outlines. It allows control on how the optimizer chooses that execution plan, right? So if I look at this picture here, we have a SQL statement and, oops, actually, let me get my pen out here. And it has a specific execution plan. That plan can then be saved to what's called the SQL Management Base, or SMB. So normally when you run a SQL statement, it's parsed, execution plan is generated, that's saved in memory. when the number of SQL statements in memory gets more than the amount of memory you have, the old SQL statements age out and those execution plans age out with it. When that statement comes back, right, now it's a new statement to the optimizer, has to rerun it, re-optimize it. And that's why you see differences in execution plans over time. The SQL management base allows you to save an execution plan, save that compiled or way to do it to storage. In this case, it's the sysocs table space. What you do once you save them is you accept a plan or make them preferred. You're saying, I would like the optimizer to choose this way to run the statement, right? So this is one of the great ways to do that. Outside of this, we normally only had execution plans in our top SQL statements in the AWR repository, or we might have some in our ASH history, again, if it met certain criteria, right? So outside of that, we had things in memory, and then we had things in our AWR or ASH. This gives us a place to manually choose where we want to store those, okay? The basic concept here is that a SQL Plan Management creates a baseline. A baseline is a stored execution plan, a stored way to do a set of steps, right? And besides those stored steps, it also keeps information on the SQL text. What was the actual SQL statement that was sent? It keeps information on bind variable values that were used, and then it keeps information on the environment the SQL ran in. So maybe you had a certain optimizer feature enabled or disabled, or you had a certain parameter set. Some of that information is kept with the profile. Not everything, but some of it that might be relevant. SPM or baselines are available in standard edition and enterprise. So that's great. You do not need any additional licensing. SPM is part of the base product, is not part of the tuning or diagnostic pack or anything else. So again, that's part of why it's in standard edition. One of the big differences between standard and enterprise is in standard edition, a SQL statement can only have one baseline per statement, where in enterprise edition, you can have multiple baselines. And we'll cover that specifically in the presentation and the demonstration. So you might have a statement that has more than one way that runs well. And so you want to be able to tell the optimizer that both are optimal in certain situations, right? Finally, in Enterprise Edition, you can do what's called the evolve process. And again, we'll cover that in a few more slides. In Exadata, they included something called automatic SQL Plan Management in 19C, and you'll see more of that in the near future. So I'll talk about that as we kind of wrap up about what you'll see in future versions 21 and into 23C. So the basic process for SPM is you capture baseline. You're going to capture plans. We don't normally capture every statement in your system, right? We try to capture ones that we think need extra help or ones that we want to influence how the optimizer is doing things. We then accept or prefer those baselines. We want to say, hey, I've captured these different ways to do the statement. I want this particular execution plan to be the one that you use, and these other ones I don't want you to use, right? So we accept the ones that we want used. We can evolve. Maybe that stuff has to change over time. We added more data. Maybe that statement runs different in a batch situation versus an online, even though it's the same statement. We evolve and we add additional plans in the Enterprise Edition that might be good. And then possibly we fix, and this is Oracle's term, fix. I like the word anchor a little better, or prefer. And we say, this is the only plan I want you to want. I don't want you to look for other ones. So the fixing or anchoring of a baseline basically says, don't look for other ways to do this, okay? If you were using the outlines feature previously, that goes back to at least 10G, might go back to 9I actually. The outlines feature is deprecated. You should move your stored outlines to baselines. Personally, I think baselines are easier to manage than outlines. You can also migrate your plans, your baselines from one database to another. And we'll just mention that again in the appendix. I have step-by-step. We just won't have time to cover the step-by-step for that. But so like if you find something in production and you want to migrate those baselines down to your test system, you can do that, or vice versa. Maybe you found that problem in testing and you make sure that baseline is in place in production when you go live, right? So, both situations are valid. So again, just kind of summarizing that process. The first step is to capture your baselines. Then you select, basically accept the ones you want to use, and then you can evolve them. There's two ways to capture your baselines, the automatic or the manual method. We'll cover both in short detail. The automatic method is using the optimizer capture SQL Plan Baselines parameter, while the manual method is using basically a PL SQL package call, etc. I should mention, I think it's in another couple slides, so we'll mention when we get there. So this is the high level process though. So you capture, and then you accept or evolve, and then you can remove baselines or maybe fix or make preferred, right? Those baselines, anchor them. So a lot of people are used to profiles. And then the question is, so why a profile versus a baseline? So let's talk a little bit about the difference between them. I have a whole nother hour-long presentation I do just on profiles also. So during that optimizer process, and the optimizer brings in your SQL statement, right? You send a command to the database. The optimizer looks at the environment, like what tables are you looking at? Do they have indexes? What columns are you putting predicates or filtering on, right? Where are you joining? And then it says, okay, based on that information, here's a number of different ways to do it. So I think of this like Google Maps, right? I want to get from my house to the movie theater. There's many roads. So why don't you give me some options on what are the ways to get there, right? So it's going to make a bunch of different options. And then hopefully it's going to pick the best one. The best one might be based on, the fastest time or the least amount of resources, amount of CPU or disk IOs, et cetera, in Oracle. So hopefully it picks the best one, and then it runs it, right? So a SQL profile influences the optimizer at that first part. When you get the SQL statement and it's compiling it and picking option and listing all the options, a profile is an embedded hint that changes the code up front. And so it changes the compilation a little bit, and it allows to kind of force a certain set of plans to get generated. It does not specifically adjust which ones get picked, okay? The baseline, on the other hand, is at the end of that process. The optimizer has gone ahead and it's it has generated a whole bunch of different ways to do this, a whole different routes for me to get from my house to the movie theater, 5 or 6 different ways. The baseline is a preference that says, I really like this one road and I really like going that route. So that's the one I want you to pick of all the options, right? So baseline is that choice option. Profiles are on the creation side, baselines are on the choice side. They can be used together. Some of the biggest differences, you can only have one profile per SQL statement, whereas you can have multiple baselines per SQL statement. So you can have multiple ways to do a thing with a baseline. With a profile, again, it's a hint. So you can only have one hint that you're adding because it's at compile time, okay? So let's look at that optimizer decision tree quickly. Again, at that beginning part, the SQL profile, object statistics gets into the generative execution plans. Once it has that list of execution plans, the optimizer has to make some decisions. Does a baseline exist? Is the plan in my list in the baseline list, right? So maybe the baseline says use index X, but index X no longer exists or something. So none of the plans generated have that index. Then it can't use that baseline, right? It's just not there. Is the baseline reproducible? Again, so it's in my list, but can I reproduce it? Can I actually run that plan? So there's some checks and balances in there. But assuming all those things are true, then it's going to run the baseline plan that's approved. If something's wrong along that path, maybe there's no baseline, maybe the baseline, the plans it's generated don't match any of the baseline plans, right? So then it's going to use one of the generated plans, right? And that's what these two kind of lower ones are. But if there's a baseline that exists and it's not fixed, it'll start adding new plans to that baseline list. They won't be accepted, but they'll be added. And we'll show an example of that in just a couple slides. But just realize that process, right? So if you've created a baseline on a statement and you haven't fixed it, made it forced, I shouldn't say forced, made it preferred or anchored, that it's going to find new plans when it can and add it to the baseline. It won't use them until they're accepted, but it'll keep growing that. So if you've used baselines before and you notice that, hey, I created one because I wanted it, but now there's a whole bunch of baselines there, that's because Oracle's job is to capture new ways to do things, and that's part of the evolve process. So we'll talk about that. Finally, if the baseline is fixed or anchored or preferred, as we would say, then use that one. Again, assuming it's something that the optimizer has generated up front, then use that one, but don't do any of this capturing part. Don't look for anything new. Just say, well, you've told me this is the only way or only couple ways you want to do it. So I'm not going to try to capture any new ways to do it, okay? So let's see, I don't see any questions. I'm going to take a quick sip here. And we're going to keep moving along. So most of the features of SQL Plan Management are available in OEM. I'm showing commands because they're easier to demo, real-time, etc. It's good to kind of know how things work. The commands are all in GitHub. These are things you can then reuse. That's, to me, a little easier for you to reuse than maybe something like a screenshot of OEM. It's good for scripting, automating, and again, you can do almost all this stuff in OEM. Not quite all of it, but a lot of the stuff. The second thing I want to talk about is the cost of a SQL plan. Frequently when people are performance tuning, what they look at is, here's the statement, SQL ID, and then here's the cost. And I always, quote unquote, want to use the lowest cost. Costs are relative, and we'll show that example in just a couple slides. So the lowest cost is not always the best execution plan. And the reason for that is because costs are based on statistics and optimizer assumptions, and they're not always right. And again, I'll show a very concrete example of that. So don't just say, I grabbed the lowest cost plan and that's always the fastest, right? Sometimes there's information that the optimizer doesn't know. Sometimes there's, that cost is not calculated, because we'll talk about how the cost is grabbed at the moment you grab the baseline, right? So that cost could change over time, but the baseline you captured is showing the cost of when it was captured, not the current cost. Okay? And of course, the optimizer is not always right. It's pretty right. It's very good. It's a very good piece of code. Has a lot of years of experience, but it's not perfect, right? It's not 100% right. It's usually pretty right. Okay, so this is that optimizer estimate versus reality. This is the same exact statement run twice. All I did was change the bind variable value, right? So if you look at the first one, you'll see here's my estimated information. That's what these E's are. And it says, I think I'm going to read one row. And then I ran the statement and gather statistics. And that's part of my execution plan here, you can see. And it says, well, actually, I got one row. I estimated one row, I got one row. So this cost is probably pretty accurate, because again, this one row, calculates out to this, and then these sum up to this 553, right? So 553 is probably pretty accurate because the actuals are pretty close to, the realities, right? But now when I change the bind variable value, I run the same statement, I just change the value I pass in. And Oracle's going to go, oh, I've seen this statement before. Let me grab it from cursor cache, and I'll just rerun it the way I ran it before. I'm going to do what's called a soft parse. I'm going to just reuse that execution plan I had before. And so you'll see the execution plan says it's fast. It's 553. And it should take this actual 0.04 seconds. Well, again, I ran this to gather stats so I could kind of show you, but reality sets in, and reality's not so good. I thought I was going to read one row, but I actually read 250,000 rows. 250,000 is a much bigger number than one, as I'm sure you can see, right? As I go up the tree then, that affects all these next steps, right? Everything else in this process took more time. And you can see that here, that it is basically, 200% slower, 0.04, it's a little bit more than 200, but sorry, it's like 500% slower, 500% slower in this process. But it still shows this cost of 553, which is inaccurate, right? Because obviously, if this line here had said 250,000 instead of one, this cost would not be 3, and then all these costs up here would be different, right? So just realize when you're looking at optimizer estimates, they are estimates. When you're tuning, we want to take these things to non-production environments. We want to run them with actual bind variable values, and we want to see what actuals are. And that might change our mind, right? So some people say I have a profile and it's running very well, and then it gets slow. Or some people say I put a baseline in and it was working fine and now it's bad. This is the kind of stuff that I usually find in those situations, is the data has changed, the data is skewed, et cetera, right? And so just realize these optimizer estimates are just that, and that once you've put something in place where that's been captured, it's going to still say that number, right? it's still going to say this number, even though reality might be different. Okay, so let's capture some baselines and get moving down this path. You can automatically or manually capture baselines. Automatically is using the database parameter. You can filter using that parameter, right? So just because you've turned on a parameter, say at the database level, that doesn't mean you have to capture every SQL statement in your system. You can actually set filters for this process to not capture everything. You can also set this at the session level, and that's what my demonstration is going to be. I'm going to go run this at the session level, automatically capture at the session, and then unset it in my session. You can also manually capture. So you can load a execution plan from Cursor Cache. So a good example of this, we had a customer with like a multi-node rack system. On one node, the statement was running fast. On another node, it was running slow. That's basically because each node has its own cache of statements. And so compilation on node 1 is not the same as compilation on node 3. We captured the baseline from Cursor Cache on node 1. The baseline is visible to all nodes. Now all nodes are saying, you want me to use this execution plan, I will, and it immediately picks that up, right? So that's an example of loading it from Cursor Cache on node 1, and now it's a baseline across all the nodes of the rack. You can also load these from AWR, that's that top SQL area. Again, that's a limited number of SQL. Your top SQL might be the top 30 statements or something, or you can load it from a SQL set, and we'll make a comment about SQL sets coming up in future versions, right, at the end of this presentation. But so these are other places execution plans are saved where you can get the baseline from. So again, that automatic capture, setting this optimizer capture SQL plan baselines, or and then I can filter it using this dbms SMP configure. And here's an example that says I'm going to capture based on text, and I'm going to say false. So I'm going to be excluding things that say test only as an example, right? So this is an example of filtering that. Again, this false syntax is to exclude. If I were to set that to true, then it would be an include filter versus an exclude filter. If you play with these a little bit, you'll get them. They felt a little complex to me at first, but not horrible. Again, I have, I believe, examples in the presentation here so you can pull. But let's go ahead and run our first demo. And I think that'll hopefully make things a little more clear. So what I have done is I have altered my session and I've set capture baselines equal to true. That's this first line here. What I'm going to do now is run a statement, and I'm going to run it twice. So one of the rules of capturing a baseline automatically is a statement has to be run at least twice in order for Oracle to say, well, it's reusable, right? If it only runs once, Oracle is not going to create a baseline for it. This is specifically kind of helpful if you have dynamic SQL, right? Out of there. So then I run my statement, and here's the actual statement. I have it formatted in the comment above, just a little more readable, but this is the statement, and I run the statement in this demo. As you might know, if I change the text, it would get a different SQL ID, so I'm very careful in here to use bind variables and run the statement the same way multiple times, so we get the same SQL ID. The one thing to note is I'm running the statement with a particular bind variable value, and this time I get one row. So just realize with this execution, I'm getting one row. I run it twice. And then here's my explain plan. And notice the explain plan or execution plan for this is nested loops with a index range scan and a table access full, right? So when I'm looking up one row, this is going to be doing nested loops with a table access full. And you'll notice that I captured a baseline. So let's go ahead and go forward. And here we can look in the baseline table, and you can see I did capture a baseline. It was auto captured. And when you auto capture something, it's enabled right away, right? So when you're auto capturing, those ones are going to be enabled right away because it's seen it more than once. It's the way it ran it. So it's going to assume it wants to enable it. Okay. Let's head back to our slides. And if you have any questions, pop them in the Q&A. I'm not seeing any right now, so I'll just kind of keep moving forward. Again, you can filter that capturing. So again, here's another one where I'm filtering the capture based on the schema name of SH. So only statements run by the SH schema are going to get captured. You can also view the current configuration by looking at the dbms SQL Management config. where parameters are like auto, right? So there's a table or a view, I should say, SQL Management config view, and you can see what the current settings are for your auto capture filtering. There's a couple other settings, but they're mostly filter type capture. And so here's an example of that output. If you turned on capturing and you're not getting baselines, here's a couple reasons why. Check your filters, right? So like here is that one where I said SQL text like test only. If I had done the false, it would say not like test only, right? So you can see what the filter looks like that it's running. You can also see if you're parsing by a schema, or if you've set a module. So if you're using modules in your code, then saying that module at the session level means it'll capture for that module. The same with you're using actions in your code. Other things, as I mentioned, needs to be executed more than once, basically twice. It has to be repeatable. The statement has to be seen twice to show up and be captured. Data dictionary, things that touch the data dictionary will never be captured. So Oracle right away saying, I'm not going to let you try to control how the data dictionary works. And that's probably a good thing, right? Okay. Manually capture, we can load a statement, like I mentioned, from cursor cast, etc. So when you load plans, you use these DBMS SPM package and you use these specific ones. You can load from cursor cache, from AWR, or from SQL set. Each of them has a slightly different syntax, but they're related. The difference is all captured plans are auto accepted by default. Plans added after the capture are not accepted, right? So here you see an example. I have two execution plans for the same SQL handle. Just know that SQL handles are used here. I know we're used to SQL IDs. We'll talk about that in just a slide, but it's the same SQL handle, basically the same SQL ID, but I have one that's accepted and one that is not accepted, okay? Here's an example of loading an execution plan from a cursor cache, right? So this is an example on node 1, it's running well with a certain execution plan hash value. On node 3, it's not. I can go to node 1, I enter my SQL ID and my plan hash value, and I've just created a baseline. It's that simple, right? Again, there's, I believe OEM allows you to do some of this also. Just the, for me, like if I'm running a rack system, I can go to node 1, I can run this. If I'm going through OEM, you just have to be careful of what path you navigated to get to that screen, so that if you're on you want to be on a specific node, you're there. This $plan count variable is the number of plans loaded. If you don't provide a plan hash value, it's going to load all the plans in, like in this case, in cursor cache. So if that statement has 3 plans in cursor cache, it's going to create a baseline for all 3 of them. So again, this is an example of where you know, like this is the execution plan I want the optimizer to use. So why do I fix or mark as preferred or anchor a baseline? So again, once a baseline exists, Oracle is going to keep saving off additional baselines that it sees. If it generates them, etc., it's going to save them off and say, hey, I might want to evolve to this, or it might be a better way to run it. When you fix a baseline, it's going to stop saving new baselines, right? It's going to stop trying to look for better ways to do it. And basically, it's going to try to use this one all the time. It's a short answer, right? So if you fixed or preferred it, that's the one you're saying use. You can have more than one fixed plan. You can have more than one baseline marked as fixed for the same SQL statement. So in my lab here, we're going to have 2 baselines that we want to be able to use. I could make them both fixed, and that would stop capturing any future baselines, but I'd still have 2 ways to do it, right? Very powerful compared to a profile, which is a single hit you're injecting. This allows me to have multiple execution plans. Okay, so to view baseline information, we're going to use this DBA SQL Plan Baselines view. This is just a screenshot of parts of this from SQL Developer, just to make it a little easier to read. But you can see here I have 2 plans for the same handle. And you'll notice again that enabled, yes, accepted, yes, fixed, yes or no, right? So some of the same information. There's lots of great stuff in this view about your baseline. So let's talk about what's in that view. Enabled, can this baseline be used? So enabled, I'll say, is that human switch. If you have the baseline and you want to manually disable it, but keep it in the system, you can enable or disable it. You can change that enable switch. Accepted is more of that, is it tested switch? Do I know this baseline is good? Do I know the SQL statement runs well? Then it's accepted. right? So there's two different switches there that you can manipulate, right? The enabled is more that like, I want to disable this baseline, but keep the information about it, maybe see what else happens, and then I could re-enable it. Accepted is, well, I've tested this baseline, I know it's fast, so I want it accepted, versus no, it's not accepted. I haven't tested it yet, I don't know if it's good. And then the fixed field, is it a fixed baseline? Is this anchored? Is this the one and only? I don't want you to look forever again for a better way to do it. Just keep this fixed and only run it this way. There is performance data there, CPU buffers, disk reads, gets, etc. This information is grabbed at the time that $SQL, I need that to be quiet, sorry. There you go. This information is grabbed at the time that the baseline is created, right? So if you're thinking that if I go look at the baseline view and it's going to keep updating the disk reads, et cetera, it's not. So like that statement I just ran twice, and it's how many of our buffer reads the CPU used to run twice is what is in the baseline. If I go run this 1,000 more times, that baseline data does not get updated with new performance information. Finally, the timestamp is the same. It's modified every time it's executed that gets updated, so you know if it's still getting used. But then there's timestamps for when you created the baseline, et cetera. Let's see. There's many more columns to look at. It's great to kind of research and get your hands around what Oracle's trying to keep track of for you. I should mention baselines stay in the repository. The default is just over 52 weeks, like it's 53 weeks. If they're not getting used, so if that last use time is not getting updated, they will get purged out. But that's after that 53 weeks. And yes, you can adjust that. That was one of the, it's not that setting, there's another setting. Sorry, I think I have it in a later slide. It's one of the settings you can change. Okay, so how do I know if my baseline is getting used? Well, in the $SQL table, there is a column that says SQL Plan Baseline. If that's execution in the cache, in cursor cache, use the baseline, this will get filled in. Note, you can also rename that baseline, and we'll get to that in 2 slides. I just want to cover one more thing before we get to that. But you can rename that baseline to make that name easier for you to understand, and we'll show you how to do that. But just realize statements match based on signature, not SQL ID. So even if you put like the SQL ID in that name, like I did here, where I put SQL ID at the front of that, that is not going to change how Oracle matches it. It matches it based on signature, and signature is based on your system-wide setting of either force matching or exact matching. So since it's mapped on signature, how do I map a baseline to a SQL ID? So they have this plan name and then a SQL handle. You can either map based on the text of the SQL, and the text is in that baseline's view, or you can map on the signature. Again, that exact or force matching. And as I just mentioned, the $SQL has that SQL Plan Baseline if it's used, but if you're looking for like, why is it not getting used? You might have to match on the signature to see if you have a baseline that exists for a particular SQL ID. And then this is the example of how would I rename a baseline. I provide the SQL handle and the plan name, and then I say I'm going to change the plan name, and then I give it the name I want. In this case, it's SQL ID underscore, and then I brought that other name forward. But you can use this how you will. Just again, realize whatever you're putting here is just a human readable name. Oracle is using that signature and SQL handle information. I feel like we should have, oh no, we'll get back to that. These will show up in the next demo, sorry. And then finally, a baseline is a stored execution plan. And you're like, well, how do I see the execution plan of that baseline, right? Do I have to run the statement and get an execution plan? No. You can use the DBMS explain package, and there is a display SQL Plan Baseline, and that'll give you the execution plan from the baseline without running the statement. So you can get that information from that. In this particular example, I am joining $SQL because I decided to use $SQL to drive based on SQL ID, and then I'm matching by signature and baseline to get this. But you don't have to do that. You can just select the explain plan if you know the plan handle, right? This is just me querying $SQL to look up a plan handle and plan name, but you don't have to do it that way, right? Just realize you can directly get the explain plan from the baseline. And when you do, it'll look something like this, right? You'll get the SQL handle, the SQL text, the plan name. It'll say it's from a baseline, right? It'll say if that baseline's enabled, you have this nice baseline information, and then you basically get an execution plan, just like you would if you did an explain plan from running a statement. So again, I'm trying to really stress the difference between like a profile and a baseline. A baseline is a saved execution plan. It's the saved steps here. And I can get an execution plan from that. You can't really get an execution plan from a profile. What you do is you run a statement with a profile and you get the execution plan from the run, right? It's a different kind of world. Okay, so this is where our next demo is going to show up. We're going to evolve a baseline, and hopefully I'll be pulling into the station here right on time. Evolving a baseline is basically the process of going, is there a better way to run this? Maybe I had an execution plan and maybe there's another execution that could be better. I can manually or automatically accept these also. The automated task verifies plans. So just very much like the tuning advisor, this will go out and actually run the statement and make sure that the better way to run it is better, and it'll accept it if it's good. And so let's go ahead and show that. Okay, so this time I'm going to run the statement, the same exact SQL statement, and I've changed my bind variable. The big thing to notice here is before I returned one row, now I'm returning 250,000 in one row. So the return is very different. And as you might guess, there's a better way to do this. So now that I'm returning 250,000 rows, but notice because I have a baseline, it still did nested loops, and it still did table access by row ID with that index lookup. But look at my cost now, 741,000. So this was not the cheapest way to run this statement. The statement is super expensive now. Why did it run it that way? It ran it that way because I told it to. There is a baseline in place, and it's going to use that baseline because I asked it to, right? That's the only accepted baseline for this statement right now. So now if we look, there's actually two baselines captured, right? One is accepted and one is not accepted. So it actually captured because I didn't fix this. I didn't anchor it. Oracle ran that last statement and it said, you know, I identified a better way to run this. And since you told me to use the baseline, I did, but I saved this better way so that we could look at it together later, right? That's what this evolve task is going to do, is allow us to look at that and find out, well, is it truly better? And again, it grabbed the cost at the moment that it did that capture. There's a question that's kind of long, so I'm going to get to that in just a minute. Let's kind of continue through the demo here and get back to that question. So now if I go ahead, and there's a feature that showed up in actually I think it's 18C, it might be 19C. We're actually going to compare the two execution plans. Again, this code's in the demo, you can see the code, but we have our two execution plans, the one that is nested loops and the one that is hash join, and we have a nice plan comparison. It's the same SQL statement, right? And then we can see the plan hash value. So this is a nice little comparison report. You can use that. The example code is in there of how to compare two execution statements, and it gives you a nice little bit of information about what the difference between them is. Okay. But note that this second execution plan uses a hash join and full table accesses, right? Versus the original one, which is where we have the accepted baseline is nested loops. So let's head back here. And let's go ahead and actually run the evolve task. So this is just going to go ahead and run an evolve task against that statement. And so here's an evolve report. So the test plan name, the SQL handle, etc. The base plan, elapsed time this, the test plan, elapsed time a lot faster, right? And then because when I ran this, I ran it in a way that I said, I didn't show the code. I ran it in a way that basically said, if the plan is better, go ahead and accept it. I don't have to manually accept it. I told the tuning tool to run it, and if it's better, accept it, right? So here you can see the plan was verified. It passed the benefit criteria because the performance was 2.8 times better, 280% better than that of the baseline plan. So the plan was automatically accepted, right? And then again, it gives us a nice little report. And now if we look at our two baselines, we can see that they're both accepted, right? So now they can both be used by the optimizer. And the optimizer is doing, if you've heard of what's called bind variable peaking, it's using histogram information, index information, and bind variable peaking to understand that in some cases, I'm going to run the statement with one execution plan, and sometimes I'm going to run it with the other one. So again, like I said, baselines actually contain some of that information about what the bind variable values were and why one plan would be better sometimes than others. And so now, if I run the statement with the one row returned, we use our nested loops and our table access full and our index lookup because that is the fastest way to do this. And if I run it the same statement where it returns 20,000 rows, we now use our hash join and our table access full because that's the fastest way to do it. And they both are using baselines, right? SQL Plan Baseline was used for this one, and SQL Plan Baseline was used for the previous one. Oops, sorry, there we go. So I've used baselines to basically control my process, but I have the ability to have multiple ways to do this because of the different reasons to run it. When you run this evolve, here we go. When we run that evolve task, this is that commit equals Y. That's where I said, if it's a good benefit, then go ahead and just accept it. That's the commit, yes, that means accept it. Yeah, again, that same, we ran the report, evolved, it was faster. Notice how we went from not accepted to now it is accepted. If you want your evolve task to look outside of your baseline, so we have our SQL Management base, which has baselines that were captured. We have what's in memory, cursor cache. So by default, the evolve task will look in those places. You can also look in your automatic workload repository. Maybe this is in your top SQL. You can look in SQL tuning sets, et cetera, right? So there's alternate places you can have these evolve tasks look. And this is just one example. But you can have the evolve look for better ways to do things in other places. Yep, so cursor cache, workload repository, SQL tuning sets. You can say only look at ones that have existing baselines. Look at new ones. Maybe create baselines from your AWR. Look at AWR. If they're good ones, then bring them in and create baselines for them, right? Or auto, let Oracle decide. Time limit, alternate plan limit. These are, how long is this task going to run or do its work? Okay, so let me get to some final thoughts and then I'll answer the question there and we'll see if there's any other questions. Baselines don't guarantee a specific plan will always be used. Again, the optimizer has to be able to generate that plan in the first place, but if it generates it in its list, so maybe it generates 50 ways to do that statement, if the baseline is in that 50 ways and the baseline is accepted, then Oracle is going to choose the baseline, right? Once the baseline exists, the new ways to do it, so those 50 ways, maybe Oracle says, yeah, you told me to use plan 38, but plan 42 looks like it has opportunity to be faster. So I'm going to store that. It won't store all 50. It'll store the ones it thinks could be faster in your baseline. And then that evolve process can look for better ones, right? The plan has to be reproducible. If an index is dropped or corrupted, a partition changes, that's going to change the plan. It's just reality, right? And so that's going to change this. That's part of why baselines evolve. The problem with profiles don't evolve, right? That's one of the big differences. So baselines have this evolve process and it can be automated, which is great. Your SQL management base, again, it's by default 10% of your sysocs table space. I'm missing a space there. But you can change that. So here's an example of changing that amount of space I want for stored execution plans to 30%. There is a weekly purging task. That's what I mentioned before. It keeps up to 53 weeks. You can change that retention. If you want more than 53 weeks, maybe you want 105 weeks, you want 2 years worth, right? You can configure that. Again, it's only going to purge execution plans that have not been used, right? So there is a last use date kept on those. And if it's not used, that's when it's going to get purged. Baselines of stored execution plans. There are a specific set of steps. They're tied to object names and structures. Changes in your system are going to change execution plans. Plans need to change. New partitions, new tables, indexes, data distribution changes. I do kind of an in-depth SQL tuning session and we talk about data distribution. It's one of those big things that I think people don't pay enough attention to, because most of our data is skewed data. Most of the data we work with is not just straightforward normal distribution, right? And Oracle's optimizer is designed to adjust. That's its job, right? That's its only job, is to look at the data, look at your request, and find the best way to do it. Again, it's not always right, but that's its job, and it's actually pretty darn good at it. Execution plans are one extremely specific way to do things. So in my demo, I had a very specific set of instructions. Do a hash join, do a table access full of table 1, do a table access full of table 2. That's a very specific set of instructions. That's what a baseline is. It's these steps and only these steps, not a choice. And the nice thing about baselines is I can have more than one way to do it. So I have a second set of steps that says, well, in this case, do this table access full on T1, but do an index lookup on the T2I index, and then do a row level lookup on T2 table inside of a nested loop, right? These are very fixed ways to do things. And so the great thing about baselines is I can have more than one way to do that. Coming soon in 19.7 and up. So 19.7, they backported this feature called automatic SQL tuning sets. In 19.8, it got turned off by default. It was meant to be off in 19.7. So if you've run across this, basically, if you've worked with SQL tuning sets are similar to this baseline idea, except for it's not, SQL tuning sets don't automatically affect the optimizer, okay? SQL tuning sets are just like a list of things you've saved because you want to look at them, or you want to tune them, or you want to provide them to the tuning tools. So in 19.7 and up now, there's an automatic SQL tuning set feature that will start capturing all your SQL statements. Not quite all, but a lot, right? So, I mentioned before, your statements go into cursor cache, they're compiled once. If you go look like a couple hours later, someone says it was slow this morning, you may not find the statement in cursor cache, and then you may not know how it ran, right? SQL tuning sets are going to start capturing everything. And now your tuning tools like baseline, so I mentioned this evolution task. So now if I'm capturing all my statements in a SQL tuning set, now when I go to evolve a baseline, it can look at the SQL tuning set of everything and see if there was better ways to run it, right? So now I'm not trying to find it on my own. In 23C, you're going to see this become more prevalent. Are they using this in autonomous database? Absolutely, right? So just expect to see where Oracle was coming from, right? So if we go back in the old days, the only place you had was cursor cache. We added AWR, we had Ash, we had SQL tuning sets. Now we added baselines. We're using these tools going forward. If something's running good, make a baseline for it so it keeps running good. You're going to see more and more baselines in 23C based on automatic SQL tuning sets, right? That automatic SQL tuning set's going to now have some history. How often does this run? Does it run well this way? Then create a baseline for it so it always runs this way, right? And then, of course, that evolution piece that I talked about. So how do I use baselines? Maybe you want to manually capture a specific set of baselines for only some troubling SQLs, right? Maybe you have a report that's bad or something. This is pretty much how most people use baseline capture, and only accept the ones you want. Do you want to auto capture? Maybe you want to capture for a schema, like the reporting stuff, and then curate a whole bunch, drop a bunch, etc. Be careful about auto capture. You really don't want to capture every statement in your system. It will try. If you turn auto capture on at the high level and you're running like a big ERP system or something, it's going to capture a lot of statements. So I would just be cautious about just turning that on carte blanche. Hybrid, maybe you want to do a little one-off capture one by one, and maybe you want to do a little auto capture for particular like reporting schema or something. You have to figure out how this is going to work best for you. Again, I try to give you a hint there of where Oracle's headed with 23C and autonomous and things. So they're using more and more of these tools to make this more hands-off. It's like the whole evolve process, just kind of every night running and figuring out what's best, and then you don't have to manage it. So with that, let me look at the question here. I have a fixed accepted baseline, run it 3 times a quarter, that finishes in 10 minutes for the same SQL signature. There's an accepted disabled baseline, takes 4 hours, and needs hundreds of temp space. Underneath, I have, unfortunately, I have tuning option. Nevertheless, the last 2 quarters, Oracle insisted on using the disabled baseline. I only have to delete the bad plan. So you said it was accepted, and fixed. I would trace it, would be my suggestion. And the trace should tell you. So what you want to do is what's called a cost-based optimizer trace, or CBO trace. You should be able to move these baselines into non-prod, or if this is a query, you can run it in prod. Run the CBO trace. The CBO trace does not require you to finish the statement. So the CBO trace does require you to purge or make sure the statement's not in cursor cache at that moment. The CBO will give you the information on why it chose which plan it chose. And I actually have a whole session, I do another hour session on doing tracing at that level, CBO trace. That's really going to give you, and so the CBO, or cost-based optimizer trace, that is tracing the process where the optimizer compiles a statement and optimizes it. And you're going to see all the gory details of why it made its choices. So that's what I would do in that case. You can delete the bad plan, but if it's disabled, it shouldn't use it. The other option is you can always open an SR with Oracle, but I'm guessing they'll ask for a CBO trace. If you're using the SQL T explain plan or SQL T tool set, SQL T can also be used to trace this. SQL T does a CBO trace as part of its steps. So, okay, any other questions? I'll just kind of stay on the line here for a minute or two. Again, please keep up with us. We have a number of events, great things going on, events.viscosityma.com. And again, the Quest database technology community, we have 3 great SIGs that meet every month: database, cloud computing, and MAA. So definitely reach out for that if you're interested in keeping up. And again, the slide deck will be shared, which has a lot of references and things in it. We'll try the second question. Is there a way to import 30 plus 11G exported baselines in the format seems to have changed? Actually, I've not tried moving baselines from 11G to 19C through export import. I know in an upgrade process, they get upgraded. But I must admit, I've not tried doing it directly as a data pump process. It probably has changed, would be my gut. You're probably right. I'd have to test that. Gives me something to test. Just trying to think if there's any other route you could take. I mean, you have to use, so for those that aren't super familiar, to move a baseline, you create a staging table. There's this SPM create stage table, and then you basically pack your baselines into that staging table, and then you move them through data pump, and then you unpack them on the target. So you don't have a lot of control over that table structure, and this is the only supported way to move baselines between databases. Yeah, I'll have to test, but I would agree. You're probably right in that the 11G stage table is different than the 12C one and up. I have not tried that process going between versions, but I do know if it's in place, if you have an 11G and you do an in-place upgrade, the baselines will come with it, and that those views and things will get updated. So, any other questions? One other quick note, as I'm just kind of filling a little bit of time here. People might be curious where the SQL handle comes from, and you're like, why not SQL ID? I don't know why not SQL ID. Again, they do a lot based on signature, but this kind of cryptic table, I'm on the right screen here. This cryptic table, sys.SQL $text, is where you will find the mapping between signature and SQL handle. This view, obviously, this is what's in cursor cache. So this is only going to be there when the statement's in cursor cache. That's the only place I found SQL handle right now. It may be other places, but that's the only place I found it. So I just wanted to mention that's in here too. So we're at the top of the hour. I don't see any more questions. I can hang on for another minute if anyone has questions. Otherwise, Monica, I don't know if you have any other final announcements or.
No, nothing from me unless you guys are in the Salt Lake City area. Yes, that's it. Thank you so much, Gary. Have a great day. We always appreciate the hour you can give us full of all these educational resources. And everyone else, thanks for joining us again. We're always appreciative that you spend an hour of your day with us during these webinars. So thank you so much. Hope you guys have a great day. Take care.
Thank you, everybody. Have a good day.